cover today something about HTML5, and it has opened up a new ways of attacking and hacking essentially XSS and CSRF, and we try to cover some of the defense as well. Before going into it, this brief introduction of mine, I'm a founder and director of a company called BlueInfy and IAppSecure. So we pretty much do assessments, on-demand scanning, consulting, etc., and source code audits around application security. In the past, I was a founder for NetSquare, and before that, I used to work with Foundstone, Chase, IBM, and so on. And my primary interest is web security research. So at a company, we try to come up with a new technique of scanning or what's going on, try to derive some ways of attacking, defending, and so on. So lots of tools are published on our site, which you can download and play around, like DOM Scan, DOM Tracer, WS Scanner, and so on. So there are some of them are addressing website, web services, and so on. Published several advisories on .NET and Java, presented at Black Hat, RSA, and so on. And these are some of the books written by me: Web Hacking, Hacking Web Services, and Web 2.0 Security. So today's agenda, what I'm going to cover today is we'll look at HTML5 attack surface. That's in the first section, and then we'll focus on CSRF and XSS, and at the end we'll cover some questions. So HTML5 vectors, looking at the attack surface. So if we go out and read some of the news articles out there right now, some of the predictions out there which says that HTML5 offers a multiple way of hijacking your websites. There is very interesting research which was published by ENISA, where they took around 13 HTML specifications and gone through it, threat modeled them, and they say around 51 security opportunities or vulnerabilities or kind of a weakness out there. So that's interesting. HTML5 is giving new opportunities for cyber criminal as well. And looking at the brief history of HTML5 or HTML, it's all started in 1991, but the major breakthrough which has occurred in HTML standard was 2005, where XHR came into picture, AJAX and DOM and etc. came into picture, and then it all of a sudden started to give a more horizon or more attack surface to browser. So in 2009, where HTML specifications were spiced up and called HTML5, and what we have is a new surface, new architecture, and new defense has come into picture. So these are the brief HTML5 specifications out there. All these standards which you are looking at, I would say 60, 70, or 80% are right now working in our browser, be it a Firefox or a Chrome or IE and so on. So now what we have is we have several different standards in it, like local storage, file system, API, then you have a drag and drop, powerful XHR and WebSockets, and so on. So if you closely look at this, pretty much what have happened is modern browser. If you take a modern browser architecture, it would look like this. What we have is pretty much over here, you have various different policies, which are sandbox, content security policy, core, SOAP, and so on. So this is a core policy layer. On top of it, what you have is a network and access, where you have XHR level 1 and level 2 calls, and then WebSockets, and then plugin sockets. So what happened is now you have, with HTML5, you have very powerful XHR object. That's XMLHttpRequest Object. Through a JavaScript, you can open a socket at the back end, connections, and so on. And even you can open a socket cross-domain as well. So we'll look at that in detail, which leads to CSRF. And then you have a fully TCP duplex connection, which is with a WebSocket, which you can open, again, through a JavaScript in your browser. So that's very spiced up network access you have. On top of it, you have a process and logic. This is a section which is really, really, really spiced up in HTML5. What you have is a very powerful JavaScript API bundled with these 4 or 3 little containers. One is called WebSQL or IndexedDB. So pretty much you can dump data like a SQL-like database, which is running on a browser, not on a server, and you can post data there. You can have a cache. In your browser, you can cache the pages. So So it's not a server-side caching, it's a browser-side caching which you can do. Amazing, you can create a file system. You can literally create a virtual file system for every domain in your browser. So say, for example, if you visit myfoo.com, I can create a little file system, and these file system can be permanent or temporary. So like I can dump a file for permanent feature. Whenever you visit the site, I have those files available. And then you have a storage, a local storage or a session storage, which allow you to store name-value pairs in your browser. So that is a very powerful storage which is added. Another one is a DOM. DOM is now DOM4 specs. So it's a very powerful DOM specs which we have, which allows you to do XPath and XML processing and so on. One of the interesting things which is added here is called parsers and threads. So now what we have in a browser, something called web workers. So web workers allow you to spin the threads through JavaScript in your browser. So we never had a threads in our browser. Now we have a very powerful threads in a browser which allows us to do a background processing. And on top of it, you have HTML5 and CSS, which allows you to have several different APIs, which is like media, geolocation, and so on. So if you closely look at the browser architecture, it is more like a thick client. It's no longer a thin client. So like we are looping back to the past, where we migrated from thick client to thin client, and now we are moving back from thin to thick. And it is interesting that these particular stack which you are looking is not just for the browser which runs on your desktop. It is applicable to mobile devices, Android or any other device you take. So that's one piece of information. The second part is there is a considerable change in the application architecture. So for example, HTML5 or applications which are running something called single DOM page application. So these applications are just one page application. You visit a slash page, it sends you a bunch of JavaScript which gets loaded, and then everything is in the single DOM. So once your application gets compromised, you're going to be on that particular DOM only, and then DOM extractions and many various different things can happen. So what you have is a single DOM, JavaScript and HTML will work through. You have a very strong policy out there called sandbox policy, which has to be followed. And then you have all these different gadgets or little modules sitting in your browser. You can use a storage, WebSQL, IndexedDB, file system cache APIs, messaging APIs, another powerful one, geolocation, other APIs, and then you can use very powerful XHR and WebSockets to communicate to the back end. So this is how application would look like. Now looking at some samples here, for example, this is a little application over here. So what we have is, this is the application. If you open a, what you call development toolbar for a Chrome, and it's a simple HTML5 application, and there is an interesting tab, resource, where you can see all these different resources which application has dumped in your browser. So one of them is definitely a WebSQL. You can see all these WebSQL. So it's a database which is not on the server side, but it's a client side. You visit a page, and page dump a data right in your page. So that's a client-side database, WebSQL. Then you go to the different pages. You can over here, you can see once you log in to the application, you can see local storage here. So these are the local storage, like a hash and ID. These are not the cookies. They are like a local storage which is stored in your browser and can be used. So that is loaded here. Then you can go a few other pages around some other pages. You can see IndexedDB here. So the token is not set yet, but you go to a particular page where a database, it's like a database call. So you get an IndexedDB call over here. If you go to login and other orders over here, you just click this claim coupon. As soon as you claim this, what is going to happen is IndexedDB will set a token on your browser. So over here, you can see a resource, and you can have a token here. So this is how a modern application would work. Interestingly, I was talking about file system. So say, for example, if you go over here, and there is a directive called file system. So you say file system, and over HTTP over here, you can say, show me all temporary files. So this is actual file system, a virtual file system which is created on the browser, sandbox to the particular domain over here. and pretty much a file system will pop up. So this particular application has created, say, temporary files on your browser page here. So you would be able to see all the files which are created for these particular applications. So you can have a permanent files as well. So you can see all these tokens files, like these are not server side, these are the browser side file systems which you are seeing. So there's plenty of different things which are added over here. All the traffic and everything will go over JSON or XML or so on. Now this is not specific to just the web browser. So say, for example, if we open the same application in, I would say, a mobile, right? So you have these mobile applications. So these are the mobile, same application using video, canvas, and all other tags using a jQuery for mobile. So what we have is a list of different applications, the same application which seamlessly work on mobile devices. So over here, we are working on simple browser. Over here, now we are working on Android browser. The same application will work. And eventually, you can actually create a hybrid application as well. So this is a simple application where you are using hybrid. So what you do is you create an Android code and bundle your HTML5 code there using a web view, and that will also seamlessly work in a browser. So pretty much, this is how HTML5 would work. And when we come to analyzing these applications, you need a different set of tools and mindset. So say, for example, if you want to analyze these applications, we need to have a strong JavaScript analysis. So over here, for example, what we have created, which you can download as well, what we have created something called DOM tracer. So DOM tracer essentially is like your JavaScript sniffer. So when you load a page, what is going to happen is JavaScript, like thousands of lines of JavaScript is going to be dumped on your browser. But when you want to do actual analysis, where I say, OK, I want to click this button, which JavaScripts are being executed. I want to focus on those pieces only. So then this particular tool is a Firefox plugin which allows you to trap only those lines of JavaScript. And what you can do is you can apply some regular expression rules. So for example, over here, we are looking for all the calls which are HTML5 based calls. So as soon as we start loading the pages, you can see all these different calls. File system call, local storage call, again, a local storage call, and so on. So pretty much this tool allows you to do analysis on your document object model. This is a database transaction tool and so on, a call. If you do a login, you can see file system being created. If you do a new order, you can start seeing, you can see these three arrows where the regular expressions matched. You can see IndexedDB calls and so on. So we are going to use these tools or these kind of utilities to perform this. So essentially what is going to happen is interaction would be user will log in. It's going to get some kind of HTML5 pages or components like audio, video, canvas, cookie, local storage, WebSQL, IndexedDB, file systems, and so on. So this is a page, or this is a one page or a one single DOM application which is running. So with this, our threat model or opportunities for threats are being changed. So what we have is these are the top 10 kind of attack vectors which we are seeing under these new light. One is CSRF with XHR and CORS. Second is a jacking. We have a click jacking, tab jacking, and so on. So there is something called core jacking, where you can load across domain resources as well. So we'll cover that. Then there is a HTML5-driven cross-site scripting, and then there are attack vectors which are attacking storage, DOM variables, exploiting browser plugins, and so on. So we're going to start covering a few of these attack vectors as we go. So the first vector which we have is CSRF and jacking, for example. So what we have is we are trying to, when you do an analysis of the browser, how they are behaving with these new policies called CORS and bypassing SOP. There are features which are added to bypass SOP. So what you have is a XHR level 1 and level 2 call, and when you have a SOP and a CORS over here. Now, one of the fundamental difference between XHR level 1 and XHR level 2, which we have with HTML5, is that XHR is no longer supporting just the binary, just the text protocol. Now, what we have is we can use text, array buffer, document, blob, form data, blob, file, array buffer, etc. So we can upload anything and we can download anything using pretty much XHR. So that's the one change. Another significant change which we have with the XHR and of course is before HTML5, XHR was strictly abiding something called SOP, same origin policy. So if your page is loaded from a Google and if you are using XHR and try to connect to Yahoo, you won't be able to connect because you are doing a SOP violation. Now this is loosened up. What we have is another policy which is kicked in called CORS, Cross-Origin Resource Sharing Policy. So if you follow CORS, then you can make a cross-origin call. So you can make, using XHR, you can make a cross-origin call. And what you have is, you have to negotiate pre-flight calls to negotiate, to access these cross-origin resources. So a few extra headers are added over here, like origin, access control request methods, request headers, and so on. So these headers will essentially allow you to talk with the cross-domain. And then what we have is, this is a clear case of more or less like you can see a opportunity or possibility of CSRF, because now you can create a very stealth channel using XHR, because XHR is by nature, it's very stealth. You can stealth channel to cross-domain. An attacker can send a payload where it says that I can control now these particular directives. So I can say, okay, my allow origin is star. So now any domain can now talk with me. So what we have is allow a stealth channel, one-way CSRF with any stream is possible. We had some restriction where you can do create a dummy pages or a dummy form, and then you can do XHR with JSON and XML, but you have to manipulate things. But over here, what you have is now you have a raw connection. So pretty much you can send any content to the server, be it a JSON or array buffer or so on. Or you can do a two-way CSRF as well. Now what we have here is, if a server is allowing to load a page over a network, which is the origin is set to star, then pretty much you can send a request, you can grab the response back, and you can do a response extraction as well. So that is how this will work. Now, what we have in a course is, when you do a pre-flight call, if you go on using certain types of content type, for example, text plain or multi-part or so on those cases, your pre-flight check will not come up. It will just allow you to allow the call to go in. At the same time, in the XHR, what you have is something called with credentials. So if you create a with credentials true, then what is going to happen is your cookie is going to replay. So in this cases, pretty much you can do internal network scanning, you can do information harvesting, you can start abusing functionalities like upload and so on. So let's take an example. You have a site where you do a login over HTTPS and you get a session cookie. Now, the site will say, okay, you want to buy some product. It will make an XHR call, and using a JavaScript, it will send the actual object, or it will send some kind of a JSON stream back to the server, and you are successful. Now, your session is still live, and you are ending up on the attacker's site. So as soon as you visit the page, what is going to happen is you will ship the CSRF load to your browser, and that browser will have a content type to avoid pre-flight and with credentials set to true. So in this case, what is going to happen is, without your consent, without your knowledge, these kind of a code, for example, what we have is we are opening a XHR object here. And now we have open, which is a post method. We are attacking or streaming to JService, which is a JSON-based service. It can be XML, it can be any other service. We are setting a content type to text plain. We are setting the credentials to true. And then we are sending a raw JSON envelope over here. It can be any other stream. So what is going to happen is, without your consent, without your knowledge, a CSRF request will get originated from your browser, and it will actually hit to your web store. And without a victim's consent or notice, a stealth attack will take place, and that's the page will get exploited with CSRF. So say, for example, if you take this particular example over here. So say, for example, we are on 100.21 right now, and we go ahead and place an order over here. So you can see the HTTP request through the burp in below over here. Any proxy, you can just trapping the request and seeing all these requests. So this is a typical GET request, and now when you place an order, it will generate some kind of a post request with a JSON. So you can see this particular JSON request over here, and your cookie will definitely get replayed in this particular case. You can see the content type is text plain, and you get actual response back. This response will not get loaded in the DOM if you don't have allow origin to start. So you get these response. Now you visit another page or another site, which is a completely separate domain, which is 121, the completely separate domain. This is not required, but just for the demo, it's there. So now what you have over here is you're streaming from 106 to 121. You are sending a raw JSON by request, and you are just firing the script. You have a with credentials true here. So this will actually replay your cookie as well. So this, when you click on go, you can see another HTTP request, which is going to get fired up. It's not yet fired up. Now we click on go here. And we will see this request over here. So this is like CSRF from 21. You have fired request to 6, cookie replayed. The only catch here is a text plain. So if your server side is validating the content that, OK, this is JSON and why this text plain, then you can have some kind of a protection here. So this is a kind of a vectors which are possible with XHR. And XHR is like very stealth because you won't be able to see anything anywhere in your browser. Because like, say, for example, when you click href, you can see where you're going and so on. This will not the case with XHR. So this will go through. Other functionalities, like say, for example, upload functionality can be exploited in similar fashion, because what is going to happen is a multi-part request on the fly you can construct through XHR page and post cross-domain. So over here, for example, you have a same web store where you have some kind of a uploading bulk order. So you say, OK, I want to upload some bulk order here, and you get a success back. So over here, there is a upload field. When you do upload, what is going to happen is this kind of HTTP request will get fired up. You have a multi-part form data over here. You have a boundary and so on. Now what you can do is you can craft a binary image file or anything which you want to create over here using XHR. So now when you visit the attacker page, what is going to happen is they will send a payload which will create something like this, where you create a stream, like a file on the fly, and then you create a boundary, then you create a XHR call over here, and then you have a content position over here, and then you fire a request, and this will actually start initiating the upload like a human has done the upload. So this is another vector which is possible with XHR level 2. Another interesting one, in the morning I think Jeremiah discussed about the internal scanning, where you can do a lot of internal scanning, a payload which is coming to you from internet, and then you have internal servers over here, like your web application server, your webmail, or your internal HR servers, and so on. Now, HTML5 based application needs a lot of interaction of across domain. So assuming that one of these application over here has access control, allow origin set to start, then what is going to happen is you can actually do not just the scanning, you can do the crawling. You can go ahead and do an internal crawling, because now you have a response extraction mechanism. You can say, OK, now I want to extract this response. When allow origin is set to star, what is going to happen is your transport layer data will actually go up into your document object model. Through JavaScript, you can start extracting these content. So over here, for example, you have over here, you are just scanning using XHR. You are saying that, OK, let me see a get whether I'm finding anything on that particular IP address or not. When you do a port scanning and you see access control allow origin is set to true, then and then you will get some content coming into your document object model. And then pretty much you have, you can go ahead and start extracting. So for example, if we go ahead and start simple port scanning, which is with a XHR, we are doing this simple port scanning. We say, OK, look around any internal IP addresses. So it will start doing any of these internal IP address and say, OK, I found 1 or 2 applications or 1 or 2 internal servers which are residing with say 21, which is say on this particular server, what you have is access control allow origin is equal to true. So now pretty much you can start crawling these sites as well, because now this is not a one-way CSRF. This is more or less like a two-way CSRF. You are establishing connection, you are grabbing content, and sending. So say, for example, we start crawling over here. So we say scan, and over here you can see what have happened is we were able to extract HTML page in the pop-up. because access control allow origin is a star. So since it is star, you actually get the content which is extracted, not one-way CSRF, it is more or less like a two-way CSRF. As soon as you go and execute the load, what is going to happen is you get this content, which is coming from a cross-domain ship you content in your loading. The only thing is your cookie may or may not replay, it depends on the browser and the specs. But pretty much, it's possible to do something which is a cookie-less, for example, any page which is lying on your internal network, and if its origin is star, then pretty much you can access. So what are the defense mechanism which we have? Very less right at this point, but you can do a content type check. You can make sure your CORS policies are in place, form and upload with the tokens that will block this. As far as the scanning is concerned, as far as the countermeasure is concerned, definitely you can use secure libraries and do a CSRF protection and stronger CORS implementation. So this is one vector. Another vector is, interestingly, being a page, being a single DOM, what you can do is you can use something using a core jacking, for example, cross-domain resource jacking. So we have these UI redressing attack, a standard one, click, tab, events, etc. Now HTML5 and RIA applications are using Flash and Silverlights and video files and so on. And all these are pretty much in an object tag or embed tag or so on. So what you can do is, if you find a single DOM application, you get an entry point into the document object model, pretty much you can start changing the underlying resource. And you can change this resource to something else. For example, over here, we have a DOM-based XSS, we have a single DOM usage, and then some kind of a Flash file sitting there. So we can extract that particular Flash file using this call, document.getElement by ID called login, item 0 src. So this is the actual login object. Now what we say is, change this object to some cross-domain resource. So what is going to happen is, over here you have a login SWF file, which is a valid SWF file coming from the domain, and now you're pointing it to something else. So over here, for example, if you want to pass on these payload, we can pass on as such. What we are doing over here is just we are using a double eval. So first eval will actually translate these resources into these text into this text, where we can pass on single quotes and double quotes, because if you pass on through the URL, it will get encoded. So if it's going through the post, then it will work, else you can use this. So now, for example, if you go over here in a demo page, so what we have here is a simple login page from, say, for example, foo.bank. It's a typical bank which is passing your. So this object is actually a SWF file, which is coming from the legitimate object or legitimate domain. Now, if you do a page source here, you can see a login.swf file here. And below that, you found one of the DOM-based XSS over here. So now what you're doing is you go ahead and do alerts, so that you will get a pop-up. It's a single DOM application over here. Now, if we go and try to access that particular file, as you can see, single quotes and double quotes will not work. It will throw a syntax error over here. Now, we go back here, and over here you can see it's a completely separate domain, which is 100.200. It's a completely separate domain. The same component is residing over here. The only difference is this little line here, this little red line here. So now we go ahead and try to change this object with that particular SWF file. So now if we go here and pass on our payload, this is a kind of a call which we want to inject into a document object model. Instead of this, if we pass on this particular string here, so we pass on this using simple JavaScript, or we can pass on in the URL itself and circulate the link. So we take this and post it into the browser as this, and you can see the resource has been changed because now you have a cross-domain jacking. So the same domain is the same, but the component is actually being changed underlying. So these are some of the clickjacking stuff or a UI hijacking stuff over here. So definitely you have these typical clickjacking stuff, but if you want to protect your browsers or protect your server against these kind of object hijacking, then pretty much an object SRC of a content security policy would kick in. Because the CSP has something called object SRC, where you can define just load the self object, don't load any other object. So CSP would kick in here. So this is more or less like a CSRF, which is augmented differently in HTML5 specs. Moving to XSS. So cross-site scripting is pretty much a well-known, pretty much I would say 90–95% application would be vulnerable to some kind of XSS. Now with HTML5, if you look at the generic sense, what you have is pretty much you have so many tags now, like new events tags, new actual video tags, audio tags, all are added. So pretty much you have all these different tags. On top of it, what you have is you have opportunity after post-XSS as well. So definitely different post-XSS opportunity comes up. So basic tags and basic XSS are very simple. You have multiple different ways to do XSS. So for example, if you have a filter, which is filtering script, blah, 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 you have some kind of a filter. Now these are the attack vectors needs to be added to check your filter, like a video, audio, and so on. So you have a video tag on a source on error you can inject. You can have an input, select, text area, keygen you can actually inject. And then you can have a form ID, test, and so on. So there are tons of different ways you can do attack. You can go to html5sec.org, where there is a very nice cheat sheet which put all these different attack vectors. Now, once you have attack successful, there are some interesting mechanism in HTML5 which allows you pretty much to do some interesting stuff here. For example, if we go over here, so what we have here is for a demo, say for example, this is a page where you have some kind of a opportunity to do XSS. So you have a search page where you can do a simple XSS over here. Now, what we are doing here is during the testing is this is the script. Now, you can see over here, HTML5 has something called iframe. And in iframe, there is an attribute called sandbox. So in a sandbox attribute, you can define what you want to do. So what we are doing over here is, in a sandbox, we have XSS. So we want to put a layer of the same domain or same page on the top, and then we can have a hook into the. So what we are doing is we are making our XSS sticky. Even XSS is a reflected one, but once it happens, it becomes sticky. Till that point you are in that particular domain, the XSS will keep on sending you signals back. So what we are doing over here is very simple. We are injecting iframe, and at the back end, we have just created a node module, which will just listening for the traffic and using for the payload and so on. And when we get some kind of a traffic back, we'll log in. Now here is interesting thing. We can set access control allow origin to star. So now what is going to happen is that particular browser can talk with us over XHR channel. At the same time, when we make a post request, we say text plain. So then what is going to happen is all pre-flight calls are not going to come into picture. So now this is our kind of a way we are passing our test load here. And this is where we are injecting iframe. And when we do inject iframe, we are saying the same domain. So domain is 121. We are just injecting the same domain over here. And the attributes which we are setting on a sandbox that's important is this. Allow same origin, allow form, allow script. So now what have happened is, since both origins are the same, we can, from our XSS, we can load the iframes down. We can access what is going inside there. And then we can pretty much, whatever we are listening, we can start sending those messages back. So now on top of it, what we have is we are just listening two fields here. The payload, oh, interestingly, you can use a push state, a history.push state, which is another HTML5 API, which allows you to change the address bar as well. So when you browse around, your address bar will also change. So then over here, and then you are listening for two fields. And when you get the two fields, anyone enters anything in those fields, you will start sending signals back. And then that is actually going to 100.6.80.80, where we are listening for the test traffic. So now in this case, for example, if we go ahead and start our watch payload, so we say node and start this. So now we have started this server, and we are setting up the URL or a payload over here with the script src 100.6 port 8080 script. So now, as you can see, what have happened here is the same page, same origin has been loaded, and the user will say, I'm on the same site. He will browse around, and whatever happening is he will do on the site. But at the back end, our iframe, they are actually on an iframe right now, is listening for all the text boxes. So anything entering the text box, we are listening. Now, say, for example, guy moved from here to a login page. So first 2 pages, 2 text box of a login can be listened as well. So over here, for example, on this particular application, you can see the messages are coming back, text 1, text 2. Just keep on a polling state. So we'll keep on getting those messages back here. So now as soon as you enter foo, your foo can be seen, foo bar, whatever you enter, pretty much you can see that as well. So pretty much there are scenarios which are changed with HTML5 on this HTML5 attack surface. So scan and defend, reflected and persistent XSS and standard XSS protection would come into picture. One another added defense which we have with the new browser is called CSP. That's a content security policy. It's based on origin, which dictates what to do and what not to do. And it has a different implementation for different browsers. So they will send actual header with X WebKit CSP, content security policy for Firefox. This is for Safari and Chrome. And then you can define what to do and what not to do on the browser. So say, for example, you say script src, just run self scripts only, and so on. So these are the key directives which you have on a CSP, like connect src, which is essentially you can dictate WebSocket and XHR connect to which resources, object src, media, img, default src, and so on. So for example, even you get XSS and someone try to inject a payload from beef or so on, and if you have script src to self only, then that particular script will not going to get executed. So this is a very interesting defense out there, but some bypasses all for this as well. But this really works for all the browsers right now which we have. So once this is in the place, some new features can be tested and exploited. So one of them is definitely a storage. So what you have is with HTML5, you have a storage API. So storage API allows you to load information locally in your browser, be it a local storage or a session storage. So what you can do is you can use a local storage API and say set item and your hash item and so on. So what you're going to see down the line is a lot of sensitive informations are going to be stored on the local storage. And interestingly, all these storage is actually stored using SQLite in your profile. So pretty much if a malware or so on grab that, then pretty much all the storage files or all the storage can be extracted. So what we are doing over here is we have a blind load which we are passing. So this is like we are checking for a content length, and then we are just setting anything which is stored on the local storage. We have absolutely no idea we can extract. So if a site get accessed or site get exploited, what is going to happen over here is, so for example, the site which we are looking at. Now this site is when after you log in, it will give you some kind of a local storage or a session storage. Now here is a payload. What we are doing is a local storage, a blind local storage enumeration, and then we grab all the local storage and then posting it to cross-domain, again the node which we used for extracting this. So passing a watch payload, instead of this, we are now passing the local storage payload here. So we start the server, and then we say, OK, pass on the XSS payload here. We are on a different IP, and this is our simple payload. If we run the loop, for example, natively in the browser, say for example, so this will give an error, just we have to get that ls variable here, which we forgot. Okay, so we get this and post in the browser, and we run. You can see there is a one local storage, which is right there. So now, instead of this, what we can do is we can pass to the search page and pass on a payload, which is again the same thing which you have shown for. And over here, we just put our, we're just listening for the response which comes back. So we are passing this on here, and we'll pretty much get the local storage back. So this is another place where, like a cookie, we have a place where some sensitive information would be residing. Another interesting thing in HTML5 is called local file system, like Windows request file system, WebKit, whichever browser you're using. So you have these full-blown file system. So say, for example, application creates a file system on your browser. So this is a browser file system, and then pretty much it has writing some tokens on the file. Here is a profile file. It has some kind of a token or sensitive information or last transactions there and so on. And if you pass on these payload, pretty much you can retrieve all different files which are residing on a file system. Another interesting factor, which is when you run a single DOM application, what is going to happen is application will create lots and lots of global variables. When you analyze a JavaScript, you will start seeing a lot of global variables. And these global variables, you check on all these different applications, there are plenty of global variables. And a global variables can be easily retrieved with these loop, and then you extract these during your XSS payload. Now, many of these global variables would have email ID, would have a cross-domain tokens, session identifiers, and so on. So this global variables can be extracted as well. So you can run this loop, and it will show you all different global variables. So this is another place in HTML5 driven application where JavaScripts, not even a developer, all these different libraries are also using global variables for storing CSRF tokens and sessions and so on. So this is another opportunity with HTML5 as such. So scanning storage, do not store sensitive information on local storage and globals, and then you need proper XSS protections. Another interesting is SQL injection and a blind enumeration vector. So what you have is you can create a client-side SQL using WebSQL or IndexedDB. So you can use an open database and execute calls. This will create some kind of a client-side data over here. And pretty much you can do some kind of a blind enumeration. So over here, for example, you can run through the Windows JavaScript loop, run through all the objects, and as soon as you find a database object, you run this select query against the SQL master database, which is SQLite database, which is residing on your browser, and you extract the table name, which is created by the user or by the application. So we got constructor database, we got a SQLite master, we got a first table, the zeroth table is a WebKit table. So pretty much if you run this loop blindly on any of the domain, you will see you will end up finding database, you will end up finding SQL results, and from that you can find the item database, and that's pretty, then next is very simple. You run 1 equal to 1 kind of attack vector or whatever you want to run against this, and you can extract data from essentially from the browser. So that's interesting. Another new feature which is added to HTML5 is called web messaging and web workers. So what you have is, we never had, say for example, you load 3 iframes in your browser page. Now these iframe cannot talk with one another. They have to send it all the way traffic back to server, and then you have to poll into second iframe. Now what you have is, with post message mechanism, what you can do is you can talk with these 2 different iframes, or you can talk with all your background processes which are created in web workers. So you have iframe can be loaded and talk with these cross domain, and a post message call will be listened. So say for example, if your JavaScript is listening for any of these post message call, then you can actually get iframe, and then you can start talking with this particular iframe. So one of the check which you can have is whether post message is set to star or your own domain. Then and then you were pretty sure that you're talking with the same iframe. So one of the check which you have is checking the origin before start listening for the new incoming or outgoing data. Now, web worker is a worker thread which you can start in the background when a page get loaded. So what you have is over here is you want to start, say for example, you have a page where you want to do checking your mail, checking your Twitter account, checking your Facebook, and everything runs at the background. So when you want to something interesting happen, it will fire back and then it will get loaded in your front page. So you can start a worker thread, which is called var worker new worker, and then you pass on the JS file which you want to run in your background. And then whenever you want to listen or send a message, you can use a worker.post message. So now you have a nice channel established between your backend connections. So now what you have is a web worker. The only thing which web worker is not having is a parent DOM. So you can't, through the web worker, you can't access these particular document object model. But pretty much you have all other features over here like regex, array, JSON, XHR, and so on. So everything you can run over here. So this thread will run in the background. Now the security issues which we have is it will not allow a cross-domain thread. So you can't point it to some other's JS and say run. But at the same time, it has a problem with XHR, it has a problem with the DOM-based XSS, and it has a problem with the DOS, which are already reported. So for example, this is a very simple example. What you have over here is you have created a thread here, which is a message.js, which is listening for your backend mails or so on. And then you're passing read and stop commands. So you're reading, when you want to read some content which is already in a back thread, you can say, okay, grab the content and put it in my placeholder. Now this placeholder where you have inner HTML used. So pretty much someone can send a live content which is going to get executed in your browser. So for example, if we go here and go to these little widgets which are created, and one of the widget is called messaging widget. Right? So you go to the messaging widget and say, read my last message, which is a background. And then as soon as you click on the message, it's going to get executed because someone has sent you a malicious message, which is tunneled through you, and then it goes to the web worker, and web worker has eventually tunneled it to the front thread. So this is another interesting scenario, and web workers pretty much works on all the browsers as well. So web worker hack possible to cause XSS running scripts. Also web worker can help in embed script. And there is something called import script, which using inside a web worker you can call a cross domain. So this is, and for the particularly for scan and defend, pretty much all the standard mechanism which you do for your DOM-based XSS, running a DOM tracer and looking for the traces and so on. So you can find that. So this is just a scratch on the surface. These are some of the few HTML5 specifications is still cooking up and a lot more to come. There are some other interesting APIs out there called File API, which allows you in handling clickjacking, drag and drop API, which can be hijacked or exploited. Cache, you have a cache API, so you can cache the pages. So for example, you're on a cyber cafe and your cache get polluted. So your browser side cache gets polluted. That's a possibility as well. So these are some of the APIs which allows you to perform rich application inside your browser without using Flash or Silverlight. So pretty much a Flash and a Silverlight is dying, and which is taken over by HTML5. And interestingly, all these attacks which we talked about is not just for the browser, it is for all mobile devices as well. So if a mobile device is running on a web view or hybrid application or typical HTML5 application, then also they can be vulnerable. So a lot is going on in HTML5 space. Here are some references and resources that are great stuff. If you go to the HTML5rocks.com, pretty much good samples out there. OWASP is running a cheat sheet project for HTML5 security where a list of good resources and good content loaded. There is a quick cheat sheet out there, which is on html5sec.org. There are some interesting resources out there on html5security.org where a list is done. And then the Kotoviz blog where some interesting observations around HTML5 along with some exploits and things are posted. So all these are good references out there. So in conclusion, pretty much HTML5 is becoming a de facto standard. It's not an option which you have. And pretty much, as we know, like browsers are broken, it looks like these packs are going to give more opportunities. At the same time, some defense are in place or embedded or baked into the browser as well. So if you are developing or assessing or auditing HTML5-driven applications, then these are the new things which we have to add in our checklist for the audit or assessment, where how these particular new calls are being implemented. So that's pretty much it from my side. I can open floor for any questions which you have. You can ask. Okay, no question. Thank you very much for listening to me patiently. And you have, like, on the slides, you have my email ID or so on. If you want to shoot questions, feel free to send across. Thank you very much.
Thank you.